Following on from our previous video, we got to this stage here. We've got to this stage here where the directional derivative is given by the dot product of our gradient vector and our unit vector. So our gradient vector and our unit vector has this kind of a relationship. So when you have your gradient vector, if the unit vector is going in the same direction, if the unit vector is going in the same direction, so the angle would be 0. Then this thing here will be at its greatest. Then this thing here will be at its greatest. This thing here would be at its greatest, meaning the directional derivative will be at its greatest when it's going in the opposite direction. When it's going in the opposite direction, so when the unit vector is going in the opposite direction, it will be at its lowest. And when it's at 90 degrees, when the unit vector is at 90 degrees, then this thing here will be 0. Then this thing here will be 0, meaning our directional derivative would be 0. So it's not climbing in height. It's not climbing in height. So in our previous video, if you're an ant walking along this path, you're not going to climb in height. Your directional derivative will always be 0 if you're walking along this path here. So we got to this stage here where imagine you've got a surface and then you cut it at a height of 4. Let's just imagine it gives you this thing here. So if you're an ant walking along this path, you're not going to gain in height. You're just going to stay at the same level all the time. So remember, for our situation here, s ticks away, and as s ticks away, you're always going to know x and y, the x and y values. So meaning you always know the position along here. You always know your x and y. Just allow me to ramble on this explanation. As time goes on, I will give you a step-by-step justification of what's going on. At the moment, just allow. It doesn't matter if you don't fully understand it. Just allow me to ramble on. You always know the position vector along here. You always know the position vector as you move along because you know x and y. So you always know the position vector. Remember from a long time in the past, we did positional vectors. If you differentiate the position vector, you're always going to get the tangent vector. So let's say if you know the position right here, if you differentiate it, it will give you the tangent vector. If you look at this point here, if you differentiate the vector, it will then give you the tangent vector. So it's at 90 degrees. So the point here is that grad f. Hang on. The point here is that grad f, this quantity here, is always 90 degrees to the tangent vector. So it's always at 90 degrees. So grad f will always be at 90 degrees. And remember, I'm not expecting you to fully understand this. I will justify it with algebra as time goes on. At the moment, I just want to give you a quick instinct into what's going on. So then the ant moving along here. Let's say you're here at the moment. If you differentiate the position vector, it will give you the tangent vector, and grad f will be this vector here, and it's always at 90 degrees to this. I will justify it as time goes on. So at the moment, just accept it for the time being. Okay. So let's say if the position vector is right here, differentiate it, it will give you the tangent vector, but your grad f will always be at 90 degrees to this. Okay.